we'd like to thank the following sponsors.
This session is all about glass, questions from architects. We asked our NGA member companies what questions they hear most often from the architects they work with. These questions encompass a wide range of topics, including building codes, safety glazing, how to select the right fire-rated glass, and understanding anisotropy and heat soaking of tempered glass. Please allow me to introduce to you the NGA advocacy and technical team who will be responding to your questions today. Tom Zaremba of Retzel and Andrus is NGA and GICC's fire, structural, and safety glass consultant. Tom has more than 30 years of experience representing Fortune 500 companies in civil litigation and financial institutions in restructurings, reorganizations, and insolvency proceedings. Tom's practice focuses on advising and representing clients in all aspects of the development of building codes and standards, including proceedings before the US DOE, the US EPA, the International Code Council, and numerous other forums. Next, Dr. Tom Culp is the owner of Birch Point Consulting, located in La Crosse, Wisconsin. After earning a PhD in chemical engineering from the University of Wisconsin, Dr. Culp has spent the last 21 years in the glass and window industry in the areas of energy efficient glazing and window performance, low-E glass coatings, and building code development. He currently represents the National Glass Association, the Glazing Industry Code Committee, and the Aluminum Extruders Council on Energy and Green Construction Codes. Nick Resitar of Retzel and Andrus is the structural and fire safety glass consultant for NGA and GICC. Mr. Resitar focuses his practice on litigation with an emphasis on liability defense in the retail and hospitality industries. Throughout the state of Ohio, he represents many Fortune 500 national and regional corporations. Mr. Resitar strives to provide his clients with an aggressive defense when necessary, while simultaneously keeping business objectives at the forefront. Irmela Sowell has 20 years of experience in the fenestration industry. She's the Technical and Advocacy Director for NGA, with duties that include managing all the technical activities within NGA's 4 committees, as well as specific roles in ASTM International, ASHRAE, and ISO. Sowell earned both her Bachelor and Master of Science degrees in Civil Engineering from Texas Tech University and is a licensed professional engineer. And finally, I'm the Associate Director of Technical Services for NGA. I oversee NGA's technical committee activities and expedite the technical publication process. My experience in the glass industry includes Tesla in Buffalo, New York, and Schott in Louisville, Kentucky. I earned both my Bachelor and Master of Science degrees in chemical engineering from the University of Louisville in Kentucky. We will be referencing many sources today, so we've compiled them all here for you. You received this in your digital handout before the conference, so feel free to refer back to that, and these are all live links that you can use to go directly to these resources as we talk through them. We also compiled a list of terms that are commonly used in the glass industry and how those are defined. So we won't go through those one by one today, but feel free to look back to your digital handout whenever you need to refer to these. All right, let's get to our questions now. Our first question is, where can I use wired glass and where is it not allowed?
Good morning, Karen. This is Tom Zaremba. I think I can probably answer that for you. Wired glass can be manufactured in many different ways, but there are 2 primary ways when you're trying to resolve the question of where can I use it and where I can't use it. 2 different ways of manufacturing it. One is in its monolithic form, and that is simply rolled wire glass, which consists of annealed glass with a wire mesh embedded in the center of it. Another way to manufacture wired glass is to apply an organic film to either one or both sides. And if you have monolithic wire glass, you have to be very cautious with it for the reason that it will break safely only if it is impacted at 100 foot-pounds or less. That's not a great deal of impact. The two categories that ANSI Z97.1 use are 180 pounds and 400 foot-pounds of impact force. So if you're going to try to use monolithic wire glass, you have to remember that it's banned in any hazardous location. If, however, you manufacture it with a organic film coating, it can, if properly filmed, meet the 18-inch or 180 or 48-inch and 400 foot-pound impact tests of ANSI Z97.1. And in those instances, it can be used in any hazardous location or any location where glass is permitted.
Excellent. Thank you, Tom. Our next question is, what is anisotropy? Is it inherent in the process?
So Karen, I'll take this one. So anisotropy is also known as iridescence, and it's the same as strain pattern and quench pattern. Anisotropy, the word itself, is more of a European terminology. So is it inherent in the process? Well, in order to understand that, you kind of need to know the heat treating process. So the heat treating process is when you take the annealed glass and heat it up to approximately 1150 degrees Fahrenheit. And the reason why you do so is in order to get the required resistance to the thermal and mechanical stresses, so that way you have safety glazing in the tempered glass. So after it's heated up, it needs to be quenched down to cool down the glass. During the quench process, the air is supplied through nozzles or slots to the glass surface. So differing levels of stress on the glass surfaces can occur during the quenching process. And also if there's non-uniform heating in the furnace, it can also contribute to the iridescence or the quench patterns. So that's why when you look through certain types of lighting conditions, you're able to see lines like you have on the screen, or sometimes you're able to see dots on certain different conditions. So that is anisotropy. So is it inherent in the process? So because it's the way you're able to capture the stresses into the glass, that's why it's always going to be inherent in the process. It's a characteristic of all heat treated glass. And it should not be mistaken as discoloration or non-uniformity of the tint or the color, and it's not a defect in the glass. The strain pattern does not affect the physical properties or the performance values of the glass itself either. In addition, NGA has a document on the iridescence in heat-treated architectural glass that discusses this phenomenon, as well as kind of goes through the different standards that talks about the viewing conditions and what's acceptable and what's not.
Thank you, Ermela. You may want to take this next question too. When specifying tempered glass, does all glass need to be heat soaked?
So heat soaking, a very controversial topic. It's important to know heat soaking in glass. So there's basically two testing approaches. Heat soak in each light, some people require each light to be tested, whereas others use a statistical approach. So the statistical heat soaking testing involves a section of a statistical significant number of glass panels to be tested, as opposed to 100% for a project. It is important to recognize there isn't a consensus. Should you have 100% of testing, or if you just have a portion of the testing. So heat soak testing is done on fully tempered architectural glass. It can be done on clear glass, tinted, low iron, patterned, or any type of coated glass on there. Within North America, there isn't a test standard. However, there's a European standard, EN 14179, that talks about two different types of heat soak. There's an inline heat soak testing, and then there's also a batch testing. Where it comes to the industry, heat soak is not a guarantee that you're not going to have spontaneous breakage. The idea of heat soaking glass is that you if there is going to be some type of spontaneous breakage due to inclusions in the glass, it will break during the process instead of, on the site. As you can see on the screen, you have some photos of an actual inclusion with some breakage of the tempered glass, and then you have the oven of how it's being used as well. So that's all about heat soaking. So in addition to the information, NGA also has a heat soak technical paper that's on your screen. It talks about the different types of heat soaking, when you should and shouldn't heat soak, as well as just some information on the actual batch process itself.
Thanks, Urmila. Okay, let's switch gears a bit to a new topic. Do all railings require laminated glass? And when is a cap rail required?
I can take that one as well, Karen. The first thing you have to realize is that when you're talking about railings, you're really talking about a defined term that's used in the International Building Code. And that defined term is guards. It also defines as a term handrails. The term railings doesn't appear anywhere in the code, and so just keep in mind that even though it's an industry term, it really refers to a defined term in the building codes as a guard. And the answer to the question, do all railings require laminated glass or do all guards require laminated glass, is yes and no. The answer is yes, because 2407.1 of the International Building Code requires all glass anywhere in a guard or in a handrail to be laminated and to be fully tempered or heat strengthened glass, which meets either 16 CFR 1201 Cat 2, which is a 400 foot-pound test, or ANSI Z97.1 Class A impact testing, which is also a 400 impact pound test. The reason that the answer is also no is because there's a single exception to the use of requirement that all guards and handrails be laminated. And that exception provides that single fully tempered glass may be used in a guard or a handrail so long as there is no walkway beneath it, or if there is, that the walkway is permanently protected. And the reason for this is the potential for, as Urmila was discussing earlier, spontaneous breakage of fully tempered glass. Now, the next question was, when is a cap rail needed? A cap rail, there are several types of guards. Glass used in guards, and one is an infill panel, and the second is typically called a baluster panel. And where an infill panel is used, the glass is in a non-load bearing position and is supported by fixed posts or rails. So the code does not require a top rail when you're dealing with glass that is structured into a guard assembly as an infill panel. That is, it is not load bearing and it is supported by fixed posts and rails. However, in the situation where you have baluster glass, either panels or other types of glass balusters, the code requires that there be a top rail or a handrail at the top of the balusters that attaches to at least 3 balusters. Now, there's only one exception to that rule, and that is if the baluster is laminated and it is tested and has been tested to remain in place after impact or breakage pursuant to ASTM 2353. So top rails are required in glass balusters. They are not required in infill panel guards.
Thank you, Tom. Thanks for clarifying that. This next one is a bit tricky. How do I apply the factor of safety for handrails and guards? Do I apply the factor of 4 that they talk about to the 200-point load or the 50-pound load? How does that work?
Okay, let me take a stab at that one as well, Karen. Glass guards and handrails under Chapter 24 of the Building Code are required to meet the requirements of 1607.8. And 1607.8 requires that the glass in guards and handrails be designed to withstand a linear load of 50 pounds per linear foot and a concentrated load of 200 pounds. Now, Chapter 24 swings back after you are aware of those Chapter 16 requirements and says, by the way, you have to build the glass or design the glass to have a safety factor of 4. But when you design the glass, you do not apply a factor of 4 to the design loads. Instead, the glass should be analyzed for each load, both the linear load of 50 pounds and the concentrated load of 200 pounds separately. And the resultant stress should then be compared to the glass strength values, which are published by NGA in a document, FM 05-12-2018. And then those values, as specified in the NGA document, should be divided by 4. So for fully tempered glass, the design stress should be compared to a 6,000 PSI for fully tempered and 3,000 PSI for heat strengthened. As to any other types of materials that are used in the guards, they do not require a safety factor of 4. So if there is concrete, steel, or aluminum components to the guards, those must meet whatever requirements there are in the code for those types of materials in Chapter 16, but they do not have to meet safety factor of 4. Only the glass in the guard or the handrail needs to meet the safety factor of 4 requirement.
Thanks, Tom. Our next question is also about railings. What if the glass is in a balcony railing, for example, in Miami? What do we do then?
All right, so Miami's kind of an unusual place. It has windborne debris requirements, and you could have glass guards like this one in exterior applications. But what the code wants to prevent in those in high wind load areas is for glass handrails on these guards to become windborne debris missiles. As a result, Chapter 24 requires the glass used in exterior handrails and guards to be laminated and comply with Cat 2 requirements of 16 CFR 1201 or Class A requirements of ANSI Z97.1. Additionally, if the top rail is attached to any other glass in the guard, that other glass must meet the windborne debris impact requirements that are specified in section 1609.2 of the building code. And those are specified for windows and other openings in buildings, but are made applicable to glass in contact with handrails in exterior applications through Chapter 24 of the building code.
I've got a follow-up question for you, Tom. For wind loading on the glass balustrade, do you consider the positive and negative simultaneously?
It's an interesting question, and frankly, I'm not aware of any building code provision specifically on this point, but what I can say is that glass balusters can differ in design from vertical posts or columns, which have far less surface area for wind to act on than if a flat glass baluster panel is used in a guard. Because of the different designs and because the wind will act differently on the different designs, those different wind requirements have to be taken into account. And specifically, insofar as positive and negative wind loads are considered, the baluster design could result in a large positive load or pressure on the windward face of the glass, which would push the glass toward the building. And simultaneously, it could create a negative load or pressure on the leeward side of the glass, which would also pull the glass toward the building. In those design type cases where the specific design of the guard could have both a positive and a negative pressure, a conservative analysis would require you to take both of those loads into account simultaneously. Now, having said that, insofar as any specific exterior design is concerned, please refer to the International Building Code section 1609 wind loads and section 4.1, wind loads in vertical glazing applications, because guards are considered vertical glazing applications under 2404.1.
Thanks, Tom. Our next questions deal with more on the energy side of things. First of all, where can I get information about glass performance values? And can I just use the center of glass performance values?
Okay, so now we're in the area where I spend most of my time, which is energy performance and green building codes as well. So as most people know, the primary energy related performance numbers or metrics that involve glass and windows are the U factor and the solar heat gain coefficient. And besides, the manufacturers will provide a lot of that data on the glass and the glazing unit in terms of the performance in different configurations, whether it's monolithic or double glazing or triple glazing. Another good source is if you look back in your handouts at the reference materials, there's a link there for the All About Glass and Metals guidebook. And there's some information in there about the different metrics in there and just general information. But generally, you'll get glass information from the manufacturers themselves. But that is generally for the glass. And so the second question was, can you use center of glass numbers? And the answer is no. For the energy codes, all the U factors and SHGC requirements are for the whole assembly, the whole window, including both the glazing unit and the framing. And that's because if you ignore the edge, if you ignore the framing part of it, you will miss out on a lot of the impact on thermal performance, as well as other issues like condensation resistance. And so you need to be looking at not just good glass performance, but also the framing system and the spacer system, and looking at things like thermally broken frames and warm edge spacers. And you have to look at the whole numbers for that. The next question is, where do you get those numbers for the whole system? Because it's easy to find one or the other, but what about together, especially in a case where the framing system is coming from one supplier and the glazing system is coming from a different supplier. And it can be challenging. But often the best source in that case is to look to the supplier of the framing system or the complete window system, whether it's a curtain wall, a window wall, or a unit window. They will often have information that with their framing system, if you combine it with a glazing system with a certain center of glass value that you got from the glass manufacturer, that'll give you an overall number. And that can be provided in most of the framing system manufacturers have that information either on their website, and some of them even have online calculators where you can go on, plug in your center of glass U factors, and for their particular window wall system or curtain wall or whatever, it'll give you the whole product numbers. And that's what's required for complying with the energy codes.
What about the labeling requirements in the energy code, Tom?
Yeah, so the first step is getting the U factor and the SHGC number for the whole assembly, as we talked about. But what does the code say about rating or labeling? And all the codes, both the IECC and ASHRAE 90.1, talk about that the U factor and SHGC must be determined in accordance with NFRC 100 and 200 technical standards by an accredited independent laboratory. So what's that mean? It means that you need to use NFRC procedures to get the numbers, to get the U factor and the SHGC, but that does not mean it has to be a physical label on each window. You may have seen these yellow NFRC labels on residential windows, and it is very common to do that on residential windows. But in commercial settings, it's far less common to see labels on each individual window. Instead, you should be looking for a label certificate or a lab report that lists all the products on the project, on the building, and the performance values for each. Now, that can be a NFRC full certification program label certificate, but reality, NFRC is only used in some cases. It's not used widely spread yet. NFRC, we're working on that to try and develop an improved system that can be used more widely. But per the code, you have to use NFRC procedures, but it is okay and acceptable to have a lab report or another certificate issued by an accredited independent laboratory as long as they use the NFRC numbers.
Gotcha. Our next question is a bit more specific. So if I'm looking at a multi-cavity IGU, on which glass surface should I place the low E coating in order to optimize the solar heat gain coefficient?
Okay, yeah, for this, whether it's double glazing or triple glazing, the way the industry talks about surfaces is you number from the outside in. So the surface facing the outside of the building is number 1. And then the other side of that, just inside, is number 2. So you can see this on the screen. And then you jump to the next slide, 3, 4, or if in triple glazing, there's a 5 and a 6. So that's the way we usually talk about surfaces. Now, to optimize solar control, you want to reject that in a hot climate where you want a low solar heat gain, you want to reject that heat as soon as possible. So you want to put it further out. Now, generally, you don't put low E coating on the number 1 exposed surface because most of the low E coatings would not survive that exposed environment. So you put it on the number 2 surface, which you can see there on the screen. And that's true whether it's double glazing or triple glazing. I will note that you can use multiple low E's. It's becoming more common to also put a interior low E coating that on the number 4 surface, and that's not there to control solar heat gain. That's there to lower your U factor even a little bit more, and that coating is durable, where it can be used on the side facing a room. Now, triple glazing, if you're going to use 2 low E coatings, there's different ways you can do it, but the most common configuration is number 2 and number 5. So that's the most outer board light and the most inner board light, but putting on the surfaces facing the cavity. A bit of warning, generally it's not recommended to put the low E coating on the middle light, either in that number 3 or number 4 surface. It can be done, but you have to be very careful about examining thermal stress when you put a low E coating in that position. And so generally it's better to avoid that. If there are scenarios where you want to do it, make sure to work with your glass manufacturer, go through a thermal stress analysis, and make sure it's appropriate.
Thanks, Tom. Next, a little bit controversial question. Are there limits on the glass area, and is New York City banning glass? And we already kind of know the short answer to that, but maybe you could elaborate a bit.
Yeah, we've been hearing a lot about this. There was some press in some statements made in the press last year, and some of them being a little over the top, that they're banning glass buildings in New York City. And the simple answer is no. No, they are not in any way, shape, or form. Now, what the codes do say about window area is that if you're following the prescriptive path, so that's a more simple building where each component of the building has to meet a certain core requirement, that prescriptive path is limited for use only in buildings with 40% window to wall ratio or less. But you can use higher than that. You can use as much glass as you want in the performance path, as long as you show the overall building meets the desired and required level of energy performance. And so the short answer is no, there are no limits on window area. But to achieve your energy performance goals, this is not the place you want to be value engineering. You do want to make sure you're using high performance systems with good low E, good thermally broken frames. There are now commercial warm edge spacers and gas fill and systems that can be used and should be used in all these applications. The other comment is some of where this talk came from is there's something called a envelope backstop. And this is not everywhere, but it is being used in New York City as well as Washington State. And what that means is when you do a performance analysis, because you do want to build a highly glazed building for all the benefits that glass brings in terms of health and wellness to the occupants from daylighting and view. If you want to do that, you have to show the building meets a certain desired energy performance level, and the envelope must meet a certain performance level. And again, that's no problem for doing a highly glazed building and bring in all those benefits of daylight and view. But you do need to be aware of both. And it's a new concept. It's not used everywhere. But we did write an article about this because it's kind of a new idea. And so if you look in Glass Magazine in the April edition, there's an article talking about some of the details regarding these envelope backstops. But the bottom line is there are no window area limits, but you do need to show energy performance and use good systems. So.
Excellent, thank you. All right, switching gears once again. Here's a frustrating one. Why isn't there just one type of fire-rated glass that works everywhere? How do I know which type I need?
I'll take that one, Karen, if it's okay with you. First of all, how do you know which kind, fire resistance or fire protection rating, to use? That's a good question. And there's really one answer, and you really have to know what the answer is in order to know the answer to the question. That is, you need to know to go to table 716.1 parens 2 if you're dealing with a fire door or a transom around a fire door or a side light around a fire door. If you're instead dealing with a window, you have to go to table 716.1 parens 3. The reason I point those out is because the answer to the question is difficult and it's spread out through the entire code. The glass industry spent about 10 years specifying each and every fire-rated fire resistance wall rating that exists anywhere in the code and tells you exactly what kind of glass, either fire protection rated or fire resistance rated glass, you can use and in what sizes and in what quantities, all set out in those two tables in 716.12, parens 2, and parens 3 of the code. Now, let's back up just a little bit. So you're going to those sections of the code to find out the answer to your specific question: what kind of glass do I need, fire resistance or fire protection? What's the first thing that table is going to ask you? It's going to ask you, what kind of a fire resistance wall is that glass going into? Is it going into a firewall? Is it going into a fire barrier? Or is it going into a fire partition? Because the answer to the question will depend on what kind of a wall it is being put into. And the reason you ask the question, what kind of wall are you dealing with, is because typically fire resistance rated construction throughout buildings is found in exit corridors, stairwells, and other areas where occupants are escaping a building that has a fire in it, or first responders are entering a building that's on fire. And depending on the height and the type of building you're dealing with and the type of exit you're dealing with, it could be a fire barrier, fire partition. If it separates two buildings, it could be a firewall. So you have to ask yourself, what kind of wall is it? And then go to those tables for the answers to the question. The second part of the question was, why isn't there just one type of fire-rated glass you can use anywhere? And the truth is there is. If you are allowed to use glass, either in a fire window or in a fire door, it doesn't matter what kind of wall it is. If you're allowed to use glass at all, you can always use fire resistance rated glass. The reason for that is that fire resistance rated glass, unlike fire protection rated glass, blocks not only the flames, the smoke, and hot gases of a fire, but it also limits severely the amount of thermal transfer that will go through the glass. Fire protection rated glass, while it stops flames and smoke and hot gas, it does not stop thermal transfer. So as a result, if you're walking by a window or a fire window in a corridor and you're walking by a room on the other side of that glass that's on fire, you could get burned from thermal transfer, even though the flames and hot gas and smoke won't reach you. So as a result, the size of fire protection rated glass is typically limited to either 25% of the wall area or to 100 square inches in a fire door in order to limit the amount of thermal transfer through the fire protection rated product. So you can use fire resistance rated products anywhere you want. If you're allowed to use fire protection, you have to be very careful that it's limited to the sizes specific that the code specifies in those two tables.
Thanks a lot, Tom. Our next question, what if I'm replacing a piece of broken glass? Do I have to replace it with similar glass, or can I replace it with similar glass, or do I have to bring it up to the current energy code standards?
Well, thanks, Karen. That's a fairly straightforward question. Glass-only replacements are considered repairs. A glass-only replacement does not have to meet the current energy code under the International Building Codes. However, under ASHRAE 90.1, if the jurisdiction follows that, the U factor and the solar heat gain coefficient must be the same or lower than it was before. Now, I caution you, that was the glass only. Now, once we get into sashes or the full window, then we're talking about a whole nother set of rules. And if you're going to replace a whole sash or a window, it has to meet the requirements of whatever code that jurisdiction is following. If it's the most current code, then you have to follow the most current code. But pivoting back to ASHRAE, if it is an ASHRAE 90.1 jurisdiction, it will allow 25% of the entire window area to be replaced with similar or same lower U factor, or similar U factor and solar heat gain coefficient, or a lower U factor and solar heat gain coefficient. So putting that into practical application, if you're replacing a few windows in a residential building or a commercial building and they don't meet 25% of the entire area, you can install windows that have the same U factor or SHGC, or of course you can always go lower, and everybody in the code world is going to be happy about that. Interior panels, storm windows are exempted because that's improving the efficiency. But ASHRAE 90.1 again says that if you are installing a storm window or an interior panel, those do have to have a low heat coating. Renovations are considered the same as new construction. That is not the same as repairs. In renovations, you must apply the code, whatever the jurisdiction follows.
Gotcha. So this next question is a similar question, but referring now to the safety standards. So for example, if I'm removing and replacing a shower enclosure to retile or seal it, do I have to bring the glazing up to the current safety code standards?
Well, that seems like a very straightforward question, but it really isn't. And I'll explain to you why. And when I do that, I'm going to draw on some unique experience I have, because not only do I participate in the code formulation process that we do for GICC and NGA, but also I litigate cases where we see the end result, usually when somebody's injured or a construction defect case. So again, going back to, you need to look at whatever jurisdiction you're in. You know, the US is an interesting place. You have some jurisdictions like Tom Culp referenced, New York and on some of the coasts that have very different code adoptions as opposed to somewhere where I am in Ohio, where in the rural parts of the state, there are places literally that have 0 building codes. With that being said, we're talking about safety, and it's always important, you know, the whole point of codes is life safety. And you need to be sure that we're keeping that in mind when we're replacing something even as simple as a glass shower enclosure. The IBC says that if you replace something in a hazardous area, which a shower is because there's water and moisture, would also go towards hot tubs, pools, anything with water. Also windows that meet certain parameters, railings like Tom discussed, and stairwells and places where people are going to be frequenting. If you install a new piece of glazing, it has to meet the safety requirements of the building code. And you do that, even, you know, best practices say you do that no matter what, regardless of what the jurisdiction says, because ultimately, if you don't and something bad happens, then you're in a whole new world of litigation. And that applies not only to the design professionals, but also the product manufacturers. You know, as a design professional, if you install or have a design that calls for the wrong material, inevitably, and something bad happens, you're going to be drug into that fight, and quite possibly the manufacturer as well, because then you get into failure to warn, whether the product labeling was sufficient, et cetera. So if you're going to replace a shower enclosure, the best bet is do it up to code, make it safe, and you're going to be happy, and your customer's going to be happy, your client.
Absolutely. Thanks, Nick. I'm definitely convinced. Our next question, what are the building code requirements for security glazing for protection in schools?
I'll take that one, Karen. The short answer is that the building codes do not offer any security glazing requirements. The codes require safety glazing in various applications. However, for security glazing, it's voluntary. There are several voluntary standards for security and protective glazing for schools and other buildings. There are some for window and door frames only. There are some standards for glass only. And then there's some for glazing systems. NGA just published a glass technical paper on security glazing for buildings, including schools, commercial buildings, medical facilities, public buildings, worships, buildings of worship, and other building types. It's important to realize when you're designing a building, it's important to determine what your threat is. What is the risk associated with this specific building type? And so based on the level, there are standards that you can use. There are several standards that has basic safety glazing, which includes accidental human impact. There are some enhanced standards that's about forced entry or burglary resistance. There's some additional standards that has forced entry and ballistics, and even ballistic protection standards. But again, those are voluntary. With recent activities on schools and shootings and things like that, there's a lot of different activity going on within the industry. It's important to note that it's a multi-industry approach. It's not just a glass or a door or a window, something to issue. NFPA 3000 is one of the standards that's out there. That's a standard for active shooter and hostile event response. They actually published this here and talks through that. ASTM International has an active task group within 2 different committees right now for the mitigation of armed aggressors in educational institutions. That scope of that document includes everything. So where your school's located on your plot of land, where is, what the different types of impact, not just for shooting, but for chemical attack as well. ICC, the International Code Committee, has an ad hoc committee on building safety and security, in which Tom Zaremba serves on that. They're also looking at this. The Glazing Industry Code Committee, a part of NGA, is working through our consultants to look as to how to help the industry look at protecting schools as well as different buildings. And like I mentioned, NGA just now published a document that kind of talks through all of the different types of voluntary standards for security. And based on your level of threat, you have different levels of security for this.
Thank you, Irmela. Okay, panelists, we have one final question, and that is, in curtain wall, does the outboard light need to be fully tempered safety glazing? And where do both lights need to be fully tempered?
I'll take this one, Karen. I've had this question come up multiple times, just even in recent months. As Nick was talking about earlier, the building code defines hazardous locations where you're required to use fully tempered safety glazing, or it could be laminated safety glazing as well. And that's in chapter 24. Now, with regards to curtain wall, especially like floor to ceiling type glass, the main provision is if it's big enough, so it's greater than a certain square footage, and the bottom of the glazing is close enough to the floor, 18 inches, and then it's mainly within a walking surface, so adjacent to a corridor or an office, a walking surface. Then it has to be safety glazing, and that's pretty clear. But the question that comes up is, does it need to be safety glazing on just the inboard light, or both lights in double glazing, or all the lights in triple glazing? And there's an exception that addresses this. So it's very clear it has to be safety glazing on the inboard light, because that's where you could slip and impact the window. Now the outboard, there's an exception 3, and it specifically talks about this. And it says that the outboard light does not have to be safety glazing if the bottom edge of that glazing is 25 feet above the adjacent walking surface. Could be a sidewalk down on the ground floor, or it could be a walking surface on a roof deck area that their building's up above. But anyways, if the window is 25 feet or higher up above that, then no, the outboard light does not have to be fully tempered safety glazing. And the idea, I guess, is that unless you're Bruce Willis in a Die Hard movie, you're not going to be impacting that from the outside. Yes, you're impacting from the inside, but if you are impacting it so much so that you're actually breaking through the window and falling more than 25 feet, it honestly doesn't matter whether that outboard light is fully tempered or not. So the bottom line is, inboard light always needs to be safety glazing if it meets this specific location and definition as a hazardous location. Outboard light only needs to be safety glazing if it doesn't fall under this exception. I think that's it.
Excellent. Thank you, Tom. And thanks to all of you, both Toms, Nick, and Irmela, for answering all these questions. I would just like to reiterate what Tom Culp said earlier about if you're looking for more answers to codes and standards questions, I highly recommend the NGA resource All About Glass and Metals. This resource combines our 6-part series that was published in Glass Magazine into one helpful reference. NGA is launching a codes and standards helpline for our member companies to submit questions for quick response. We'll have options to submit your questions in an online form, by email, or by phone. So look forward to more information about that new resource coming out shortly. So we're back again, and we have some great questions. The first one here, are there any standards which measure what is acceptable for anisotropy?
Karen, I'll go ahead and take that one. Currently, there aren't any standards. However, ASTM C14, which is the Committee on Glass and Glass Products, has within its subcommittee C1408 on flat glass is working on a new test method for measuring anisotropy. They had a ballot that went out early June, and the ballot results came back in July. And so now the task group will be working through some comments, and hopefully they can get that one wrapped up soon, but look for it coming up.
Thanks, Irma. This next one, why does the exception for requiring laminated glass in a guard only consider the people on the ground? If there's spontaneous breakage and the guard is no longer in place, isn't this a hazard to anyone on the elevated surface, especially children?
I can take that one, Karen. NGA's Glazing Industry Code Committee was the author of the provisions relating to, many of the provisions relating to guards, including the exception for fully tempered if the walkway, or if there's a walkway below, is permanently shielded from the potential for falling glass. And I can tell you that there was extraordinarily spirited debate at the GICC meeting where that exception was discussed, and it was included in the draft proposal that was submitted to the International Building Code. And there was spirited debate at the hearings, but ultimately it was adopted. And you're right, there is a risk if spontaneous fully tempered glass breaks, it leaves a hole in the guard. Sometimes, not always, sometimes spontaneous breakage creates spaces in the multiple breaks in the glass, which can actually squeeze the glass even tighter into the space that it's in the guard. However, that isn't really the reason. The reason is that there was a lack of any significant data of people falling through a spontaneously broken guard. Parents tend to find those types of things fairly quickly and don't allow their kids to play on the balcony until it's been repaired. Likewise, if there's a spontaneous breakage inside a commercial building, for example, and the walkway below is guarded, those things tend to get repaired fairly rapidly. And unless there is some evidence to substantiate injury warranting the additional cost, it was adopted by the building codes in this form. Thank you.
Thank you, Tom. In a remodeling project, if the glass in a hazardous location is still in good condition but doesn't meet current safety standards, can I add a film or do something else on site to meet those safety standards, or do I have to replace the glass?
I can take that. If you have a situation where you have a good piece of glass, but it doesn't come to current code, can you add a film to it to bring it up to code? The answer is no. That will not bring it up to current code. It'll probably make it safer, but it will not bring it to current code. In order to meet current code, if there is an ANSI Z97 or 16 CFR requirement requiring safety glazing, that type of glass has to be tested before it's installed to ensure that it meets the standards. So simply applying a film retroactively will not bring your glass up to code.
Got you. Thanks very much.